Okay, question 9 asks, how many even integers are there between 200 and 700 whose digits are all different and come from the set that includes 1, 7, 9, 3, 4, and 2? I've gone ahead and I've gone out 200 to 700, that's the interval, and I've rearranged these from least to greatest. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, 7, and 9, my bad. And so to tackle this question, we need to figure out first which digit we can place in the hundreds place from 200 to 700. Those digits are 200, 300, and 400. And each of them must be 3 digits, right? 200, 300, and 400. So, if it's even, an even number has a 2 as a multiple of 2 in the last place. Here, however, it says we can't have repeating digits. So we have 2, that means this 2 is unable to be there. The only digit we can have in the last place is 4. For 3, we can have either 2 or 4 in the ones place. And for 4, again, we can't repeat that 4, so we can only have a 2. That's going to make it a lot simpler when we have to find out the number of digits, or the number of integers in these hundreds places. So, in the middle, we can't repeat digits, so we can't have a 2. We can have 1, we can have 3, 4, 7, and 9. Those are the digits we can have as a middle. Same thing here. We can have a 1, we can have a 2. Can't have a 3 because it's in the hundreds place. We can have a 4, a 7, and a 9. And over there, with the 4, we can have 1, 2, 3, 7, and 9. Let's go ahead and write these. 1, 2, 3, 7, 9. So that's how you set up a problem like this. This one is a little bit easier because there's only one of these numbers that we can have to make it even. So it can't be 4 because it can't repeat. It makes things a little bit easier. And over here, it can't be 2. So we can figure out how many possible integers we can create. So there's one option for the hundreds place. There's 1, 2, 3, 4 options for the tens place, and there's one option for the ones place. There's a total of 4 integers that we can create in this, such that it's even and doesn't have any repeating digits. This one's a little bit more complicated. We have 1. What if we do 312, but we can't do 322? So for that, there's only 1, 2, 3, 4 options in the middle. And it's the same thing here. If we're doing it with 4, we can't have this one. So no matter which way we take it, there's only going to be 4 numbers that we can have here rather than 5. But there's a choice of 2 digits for the ones place. So 1 times 4 times 2, 8 possibilities, right? Same thing over here. 1 possibility, 4 possibilities, 1 possibility, so a total of 4. You add those up, you can get 4 plus 4 plus 8, which is 16 total. There's 16 total. If you want verification, you can create the integers themselves. I can have 213, 234, 274, and 294. Here, I can have 312. Can't have 322, but I can have 342, 372, and 392. I can also have 314, 324. Can't have 344, but I can have 374. And I can have 394. Same thing over here. I can have 412, 432, 472, and 492. This is 4. This is 2 times 4, which is 8. And this is also 4. So you have a total of 4 plus 8 plus 4, 8 plus 8, 16. So there's 16 total integers between 200 and 700 that can be created using the digits in this set and without repeating any of the digits. Thank you. Leave that up for a moment so you can look at that.